Okay, so this is the notes on 3.1 forces. And here's a kangaroo surfing sign. These are the Australian surf signs. So what is a force? A force is a push or a pull on an object. A force is a push or a pull. Sometimes it's obvious that a force has been applied, but other forces aren't as noticeable. Changing motion. A force can cause the motion of an object to change. Okay, if we have an unbalanced force. Remember, all the forces combined are called the net force. Force does not always change velocity. When two or more forces act on an object at the same time, the forces combine to form the net force. Gravity pulls down. The normal force is pushing up. Air pressure is pushing down. Pressure in your body pushes back. All right. Different forces. Different forces. Balanced forces. Forces on an object that are equal in size and opposite in direction are called balanced forces. When the forces are balanced, there is no movement. Okay, there is no movement. Unbalanced forces. When two people pushing on a cart are pushing with unequal forces in opposite directions, a net force occurs in the direction of the larger force. They are considered to be unbalanced forces. Friction. Friction is that force between any two objects. Okay. Friction between the water and the surfboard. Suppose you give a skateboard a push with your hand. Does the skateboard keep moving with constant speed after it leaves your hand? The answer is no. It's going to slow down because of friction. Because of friction. The force that slows the skateboard and brings it to a stop is friction. Friction is the force that opposes the sliding motion of two surfaces that are touching each other. So then what causes friction? If two surfaces are in contact, welding or sticking occurs where the bumps touch each other. There's the little peaks and valleys on every object, no matter how smooth. These are called microwelds, and they are the source of the friction. I put this picture of this old surf magazine up here because I'm not sure what's more amazing. Is this little kid can surf, or he's so small and surfing, and yet he's wearing a diaper. So it's just weird. He knows how to surf, but he still is wearing a diaper. I don't know. Sticking together. Those micro welds between the big kahuna here and his feet, those are micro welds. It's holding him to the ground. To move one surface over the other, a force must be applied to weaken those micro welds. It's going to take a big force to move kahuna. By the way, if I'm at the beach, I'm hanging with that dude because obviously he knows where the good food is. Static friction. Static friction is a frictional force that prevents two surfaces from sliding past each other. This force is the friction force due to microwelds. Sliding friction. Beautiful. Look at this, man. Sliding friction is a force that opposes the motion of two surfaces sliding past each other. Now think about what they do. You wax your skis, you wax your snowboard, you wax your surfboard. Why are you putting wax on that? To get rid of those little peaks and valleys. It makes it smooth on the bottom. It cuts down on the friction so you have a better ride, faster ride, less friction. Rolling friction. Rolling friction is a frictional force between a rolling object and the surface it rolls on. What is gravity? Gravity is an attractive force between any two objects that depends on mass and the distance. The mass is in the distance between them. And remember, gravity is a basic force. Gravity is one of the four basic forces. The other basic forces are the electromagnetic force, the strong nuclear force, and the weak nuclear force. This is huge. The law of universal gravitation. Isaac Newton formulated the law of universal gravitation, which he published in 1687. And here it is: the forces acting on objects. You use the universal gravitational constant. And we're not going into this number right now. Again, this is for advanced physical science. Masses of the two objects and the distance squared. The law of universal gravitation enables the force of gravity to be calculated between any two objects if their masses and the distance between them is known. According to the law of universal gravitation, the gravitational force between two masses decreases rapidly as the distance between the masses increases. But no matter how far apart two objects are, the gravitational force between them never completely goes to zero. So that's right, little old Pluto way out there. There is a force of gravity between you and Pluto right now. There is a force of gravity between me and you students. There's a force of gravity between any two objects that have mass. Because the gravitational force between two objects never disappears, gravity is called a long-range force. And here's a story out of the book. In the 1840s, the most distant planet known was Uranus. The motion of Uranus, calculated from the law of universal gravitation, disagreed slightly with its observed motion. As a result of these calculations, the planet Neptune was found in 1846. Close to Earth's surface, and this is Earth's gravitational acceleration. Close to Earth's surface, the acceleration of a falling object in free fall is about 9.8 meters a second squared. This acceleration is given the symbol g and is sometimes called the acceleration of gravity. They used to show sidecar racing on TV all the time when I was a kid. Deadly sport. You just watch it sometime. These motorcycles go a couple 100 miles an hour with this guy hanging over the edge. Crazy. By Newton's second law of motion, the force of Earth's gravity on a falling object is the object's mass times the acceleration of gravity. The gravitational force exerted on an object is called its weight. Because the weight of an object on Earth is equal to the force of Earth's gravity on the object, weight can be calculated from this equation. W, or weight, equals the mass times 9.8 meters a second squared, because that's the acceleration of gravity. Weight and mass are not the same. Weight is a force and mass is a measure of the amount of matter in an object. Weight and mass are related. Weight increases as mass increases. The weight of an object can change depending on the gravitational force of the object on the object. Mass remains constant no matter what the gravitational force. So your mass will always stay the same, but weight can change because gravity pulls on your mass, creating weight. All right, that's it for these notes on 3.1 forces.